Okay, so let's begin. So if you look here in my notes, you will see that for inverse matrix, the condition is it must be a square matrix, and then the determinant of this matrix, it will be not equal to 0, right? That means it is a non-singular matrix. So but here if you look at the fourth option, so it is said that determinant of A, this is 0. So according to the condition, this is not true. So we can say that our B option, it is right. Okay guys, and I'll show elementary matrix later on. And these options they have taken from, they are mostly taken from the conditions. Okay, conditions for invertible matrix, or condition for inverse matrix. So if you look back to our the lecture of our Laushi, so you will find the condition of inverse matrix, and this option basically they are taken from those conditions. So according to the condition, the second option is correct. Okay guys, and now, okay, yeah, Lab, welcome. No, Zakira, you didn't miss too much. We just started from the first test paper, and we just solved some MCQ. So I'll send the recording later on. And let's see the fifth question here. So we have a matrix, and its value is 5. So then which of the following inequalities is not true? That means which of the following option is false? So the first question here, if you see, like we just changed A, B, C. Okay, so we just changed the first column with the third column. Okay, we exchange the first column with the third column. So if we exchange those columns, so we have to multiply a minus. Okay, if we if we exchange the column, we have to multiply a minus. So you see here our value was 5, so we have multiplied a minus sign here. So it is minus 5. That means it is true. And then, I mean, for it is true, that means this equation is true. But for this particular question, we can say that we cannot take this option, right? Because it is true. And then for the second option here, so if you just see that we have done a row operation, like we have multiplied the minus here, right? And then we have multiplied the first row. We have multiplied the first row. Sorry, we have subtracted the first. We have subtracted the second row from the first row. You see here, the if you look at the row operation here, we have subtracted the second row from the first row, and then we have multiplied the minus here. So we can see that if we just take this minus out, so we will get this one. Okay, and then the answer will be, I mean, if you just see, like we have 5, so here is 5, and then okay, and then this value here, it will be 5, right? Because it is given here 5. So 5 multiply a minus sign, it will be minus 5. And then for the third question here, we have minus 3a, minus 3b, and minus 3c. So if you see here, we have minus 3 multiplied with the first row. So we can take this minus 3 out, and then we will find our this row, A, B, C, D, E, F, and J side. And for this row, the value is 5, right? The value is 5. So minus 3 multiplied 5, it is minus 15. So we can see that this option, it is not correct, right? So that means our question was which of the following inequalities is not true. That means our option will be C. Okay, you see here our option will be C, because this is not correct. So that's why this is the answer. Okay guys, and then for the fourth question, okay, so, and for the fourth question here, it is A, B, C, minus D, E, F, and 2G, 2H, and 2I. So if I take these 2 out, so I'll get 2 here, and then I have to take this minus out, so I'll get minus 2. I'll get ultimately I'll get minus 2. So minus 2 multiplied, then we will end up with with this example, we will end up with this, right? So if you just substitute the value here, so -2 multiply 5, so it will be minus 10. So that's why this is also correct, and our right answer will be C. Okay, so now let's get back to the part 3. So this is the calculation part, right? We have to calculate the we have to calculate matrix multiplication. So we know that for matrix multiplication, we go from left to right. We go from left to right, and then top to bottom, right? So we have the first entries here, 4. So we multiply 4 with 7. It will be 28. Then we add the second multiplication, that is 3 multiply 2, that is 6, and then on multiply 1, that is going to be a 1. So our Laushi did mistake here. Okay, this is not correct. So 28 plus 6, it is 35, right? Okay, so it will be 35. Okay, Laushi did a mistake here. And then for the second entries, so if you look here, we have a so for matrix multiplication there is 2 condition. Okay, if you just look here, have I written here? Yes, so for matrix multiplication we have 2 conditions. The first condition is the number of column of the first matrix and number of row of the second matrix, they must be same. Okay, and the second condition, and there is on condition. Okay, so just the number of column of the first matrix and number of row of the second matrix, they must be same. And then the size of the multiplication result, or the size of the result, it will be this way. Okay, the number of row of the first matrix and number of column of the second matrix. So as we see here, for this particular matrix, our result will be a 3 by 1 matrix. Okay, and we can see here we have so we have the first the number of column of the first matrix and number of row of the second matrix, they are similar, right? So okay, so it will be a 3 by 1 matrix. So that means it will, our Laushi has written the wrong way, right? So it will be this way. The first entry, it will be 35, and then for the second entries, so let's calculate that. Okay, so here we have 1. Okay, sorry. So here we have on, so on multiply 7, it will be 7, and then -2 multiply 2, that will be -4, and then 3 multiply 1, that will be 3. So 7 minus 4 plus 3, it will be 6. Okay, it will be 6 here. And then let's go to the third row. So 5 multiply 7, it will be 35, and then 7 multiply 2, it will be 14, and then 0 multiply 1, it will be 0. So the answer is 39. Okay. Oh, okay. So it will be 14, right? So it will be 49. Okay. So you see here, this is the result. 35, 6, and 49. Okay. So our Laushi did this to write, but this is not correct. You can check using a matrix calculator. Okay. Okay, fine. So let's see the second question. So here it is a 1 by 3 matrix, and here we have a 3 by 1 matrix, right? So how do we calculate this rank? Just take the number of row. So we have only on row here, so that's why I have written here 1, and then take the number of columns. So we have 3 column here, so that's why I have written here 3. Okay. So this way we find the rank, and then we just find the size of a matrix. So you see here, these two value, they are same, so that means we can multiply this matrix, and then the result will be a one by one matrix, right? So if you multiply this way, right, from left to right, and from top to bottom, so okay, so the answer will be 1 multiply 3, it will be 3, then plus 2 multiply 2, it will be 4, and then plus 3 multiply 1, it will be 3. So 4 plus 3 is 7, and plus 7 plus 3 is 10, right? So the answer is 10. So this way you solve the first, you solve matrix multiplication. So guys, can you understand?
Yes, Amar.
Okay.
Yes, Omar.
Okay.
Yes, Omar.
So these are very simple question. Okay. So let's go to the second option. We have the matrix A, and we have to find the inverse matrix through elementary row operation. So you have to write down. So if you look at my notes here.
Hello.
Okay, how is that? Okay. If I go up. Okay, so see here. To find the inverse matrix of n by n size, so the formula is, so it must be a square matrix. Okay, to find the inverse matrix, the condition is it must be a square matrix, and then the determinant of this matrix, it will be not equal to 0. Okay, so that means it is non-singular. So this is just two conditions to find inverse matrix. And then how do we find it? How do we find them? So we just write down this matrix and the corresponding identity matrix on the right side. Okay, and then we do row operation, and finally on the left side we have to bring some kind of identity matrix, and on the right side we will find our inverse matrix. Okay, so if you look here, okay, so if you look here, our Lassie has written the matrix here, and has written the corresponding identity matrix on the right side, and then she has done row operation. So if I just okay, so let me use a matrix calculator. If you guys if you guys want to make sure with the, if you want to make sure the results, so you can just use this calculator. So here is linear algebra option, and then we have to do reduce row operation. Okay. I have to charge my battery. Just a moment. Yeah, now perfect. Yes, sorry. So we have to reduce we have to make it to RREF, right? Or we have to convert this to a identity matrix. So it is 23230. Okay. It is a 3 by 3 matrix, so we're going to find the inverse matrix, right? Matrix inverse. And then it is a 3 by 3 matrix. So we just write down our matrix here. The first entry is 2. Sorry. It will be a 3 by 3 matrix. And so the first entry here is 2, then 3, and then 2, 3, 0, and minus 3, minus 5, 0, and then -3, -6, and 1. So if I calculate these two, 3, 0, -3, -5, 0, -3, -6, 1. Okay. So if we use a Gaussian Jordan elimination, and then you see like on the left side we have our matrix, but for now we have to do row operation, and we have to convert this left part as an identity matrix, and our right part it will be, so our right part, okay, our right part it will be a inverse matrix. So you see here the first row operation, the second row operation. So we have done some row operation here, and on the left side we have got our identity matrix. So the inverse matrix will be on the right side. Okay. So this part here it will be our inverse matrix. Okay, this part. So you can see here the inverse matrix is 5, 3, 0, -3, -2, 0, and -3, -3, 1. So this way you can easily find the inverse matrix. So even if you don't know how to do, or if you're not sure about the row operations, so you can just have a look here. Okay, I have already given the link in the widget group. So okay, yeah, sure, I'll give this link in the widget group. It's just to make sure that our answer is okay or not. So you also need to learn how to do this row operation by your hand. Okay, and they have explained all the row operation here for you. You can just have a look and check your answers. So guys, let's go back to our question. So you see, this is our inverse matrix, right? Sorry. This is our first matrix, and we do row operation, and we get identity matrix here, and on the right side there will be our inverse matrix, right? It will be our inverse matrix after doing row operation. So okay, I think you guys can understand, right? So number 3, we have to solve the following linear system by Gaussian Jordan elimination. So we just take out the coefficient of x1, x2, x3, and also of the coefficient of the also have to take uh, this this numbers on the right side. I mean, okay. So let's see here. What is the answers? Okay. 200. Okay. So guys, if you look here, so number 3. Okay. So 132. Part 3, and so we can still use this matrix calculator to find that. So you see the question here. It is said we have to find. Okay. We have to solve the following linear system by Gaussian Jordan elimination. So you just need to write down the corresponding uh, you just need to take the coefficient. Okay, you just need to take the coefficient and write down here. So if I just take this coefficient, so we have to find the Gaussian Jordan elimination. So okay, so this is this will be a for 3 by 4 matrix, right? If you look here, we have 1, 2, and 3 row, and we have 4 columns. So it will be a 3 by 4 matrix. And then I just write down here, it will be a 3 by 4 matrix, 1, 2, 3, 4. And then I just write down the coefficient here. So the first one is 1, right? Second one is 5, third one is 1, and fourth one is 11. So I just write down this way, 1, and then -5, and then 1, 11. Oh, it is okay. On -5, 1, and 11. So it will be 5, 3, 6, and -1. 5, 3, 6, and -1. And here will be 2, 4, 2, -6. 2, 4, 2, -6. So I have written the I have taken the coefficient here, 1, -5, 1, 11, 5, 3, 6, -1, and then 2, 4, 2, -6. Okay. So you have to check mark here. Okay. We are going to reduce to we are going to reduce it completely. I mean, we are going to find the RREF form. Okay. So if I just calculate here, so you will see that okay. So if I do row operation, you will see at last we have we are end up with this equation, right? So one okay, if I write down here, we have got 1, 0, 0, 1, and then 0, 1, 0, 2, and then 0, 0, 1, 0. So okay, so we have got this one, and then we have to write down the we have to write down the value of x1, x2, and x3. Okay, so if you look here, we have x1 here, x2 here, okay, and x3 here, and x4 here, right? So you have to imagine a line here. Okay, just you have to imagine a line here in your brain. You don't need to write down this line, but it means that as this part, this x4 is on the right side, so we can say that this x4, it will be also on the right side of the solution, right? So we can see that here is x1. X1 is equal, okay, if I just use this highlight, so we have x1 equal 1, and then we have x4 equal on. So we can write down this way, like on into x1, okay, and then it will be the answer will be 1. Okay, so I think you can understand here. Okay, just a moment. Okay, so just now write down like the solution. So here is 1 into x1, so I can write down x1 is equal, it will be x1 will be equal to 1, right? Because on the right side we have 1, so x1 equal to 1, and then here it is x2, right? X2, so x2 will be equal to, it will be equal to 2, right? Because on the right side we have 2, and then here it is x3, so x3 will be equal to 0. Okay, x3 will be equal to 0. So this way we calculate, or we solve a linear system using Gaussian Jordan elimination, and here is our answers. Okay, and you can just write down answer set will be answer set will be this way. Just okay, you can also write down this way, 1, 2, and 3, 1, 2, and 0. So this is the answer. So now let's see. Okay, so guys, can you understand this part?
Yes, Amar. I think it will be -2.
Where it will be -2, right? Okay, let me see. Yeah, it will be -2, right? I'm sorry, it is -2. Okay, it will be -2 here. x3 is equal to -2. Okay, so it will be -2. As you see here, we have got -2, right? It is -2. Okay, so let's move forward. Guys, can you all understand how we solve this? Yeah, I will record this. Yeah, and I will record this and upload. You don't worry. Okay. So now let's see the next question here. We have to evaluate the determinant of this one. Number 4. X minus 1. Okay. I need the answer. Like if I write down here, so it will be a long answer. So I just need the answer where I did this. Just give me some time to find those. So we have to reduce this row. Okay, we have to reduce this row and we have to find the determinant. So for this reason, I can do this row operation R1 plus R2 plus R3. Okay, R1 plus R2 plus R3. And if I do this row operation, so you see that it will become so x minus 1, then minus 1, then minus 1. Okay, I'm going to add the first row, second row, and third row, and I have to replace the answer into the first row. Okay, that means R1 plus R2 plus R3, and I'm going to replace that in the first row. So it will be x minus 3. Okay, x minus 3, and then the remaining part it will be same. So it will be minus 1 and it will be minus 1. Okay, so and for here it will be also x minus 3 if you do the row operation. So you will see that i'm just going to uh, I'm just going to add the first row, second row, and the third row. Okay, so you will get x minus 3. So here we will also get x minus 3. Okay, and for the second and third row, I'll keep it same as it is. Okay, it will be x minus 1 and minus 1. It will be minus 1 and x minus 1. So guys, can you understand? I have just done this row operation. Okay, I have added the three row and I have replaced. I have written the answer on the first row, and the second and third row they are same.